atomic number, atomic mass, and isotopes. Let's welcome the three subatomic particles: proton, neutron, and electron. What's the relationship and how can they be determined? Let's begin with protons. As we know so far, protons are made with two up and one down quarks. They have a positive charge and they are located in the center of the nucleus of the atom. But what else are protons useful for? Protons give the identity of an atom. This means that an atom that has one proton will always be hydrogen. With two protons will always be helium, etc. As a result, the modern periodic table is arranged by the number of protons, also called atomic number. Now let's talk about neutrons. As we know so far, neutrons are made up of one up and two down quarks. They have no charge and they are located in the nucleus of the atom together with the protons. But what else do we know about neutrons? Neutrons are known to have almost the same mass as protons. The unit of mass is called atomic mass unit, or simply AMU. Adding up protons and neutrons, we get what is called the mass number. Now is the turn of electrons. Electrons are made of leptons and their electron neutrinos. They have a negative charge and they are located spinning around the nucleus in a cloud. But what else do we know about electrons? Electrons are known to be the smallest subatomic particles and also have the smallest mass. In here we can see that you need 1,830 electrons to have the same mass as a proton. The natural state of an atom is to be electrically neutral. This means that the number of protons and electrons are equal. Now it's time for the isotopes. Let's take a look at these fish. Most of us will identify them as sharks, and they certainly are. However, take a closer look and you will find differences among them, giving them special traits. Isotopes are known as a different version of the same atom, where the number of protons and electrons are equal, but the number of neutrons vary. In this example, we have hydrogen and his three isotopes. In the first isotope, we have one proton, 0 neutrons, and 1 electron. In the second example, we have one proton, 1 neutron, and 1 electron. And in the last example, we have one proton, 2 neutrons, and 1 electron. As you can see, the three isotopes have the same number of protons and electrons, and the number of neutrons is the one that varies. The first one is called protium, the second one deuterium, and the last one tritium. Now let's learn how an isotope is represented. We use in the middle the symbol of the element. Then on top we will write the mass number, that, if you remember, that's the number of protons plus the number of neutrons. And at the bottom we will write the atomic number, that is the number of protons. Applying it to the previous example for hydrogen, then we will have the first protium will be H1, 1. For deuterium, it will be H2, 1. And the last one for tritium, it will be H3, 1. Indicating the one that all of them has the same number of protons, meaning that is hydrogen. Another example using lithium. In here we can see lithium, that is the third in the periodic table. As a result, we can see the 3 at the bottom in each one of them. And the number of neutrons is the one that varies. In the first one, it has 3, so that gives us a 6 as the mass number. And the next one is 4, that's why it gave us 7. and the last one it has 5 neutrons, making up a mass number of 8. Now, having 2, 3, or more isotopes brings us a problem when trying to report the mass of an element. In case of lithium, will we report 6, 7, or 8 MeU? As you may have guessed, neither one. What we need to do is to get a weighted average of their masses, also called atomic mass. In this case, for lithium, we have 3 isotopes that we are considering. That is 6, 7, and 8, so the mass is the same one. And we will need what is called abundance, that is the percentage of abundance of that isotope in nature. For isotope 6 is 7.59, and for isotope 7 is 92.41. For isotope 8 is just traces. So we multiply the 6 times the abundance. In this case, it will be 0.0759. And for isotope 7, we'll multiply the 7 times 0.9241. Adding up, that'll give us 6.92. And as we can see now, lithium in the periodic table appears with 6.94. The difference between our calculation and the number that appears in the periodic table is basically the traces isotopes. Let's sum up. The number of protons we learned that is the same as the atomic number. The number of protons is the same as the number of electrons. When we add up protons and neutrons, we get the mass number. And multiplying the mass number times the percentage of abundance of all isotopes, we get what is called atomic mass or average atomic mass. There are 2 ways that we can notate this. The first one in the left is usually for isotopes. We'll write the symbol and on top the mass number, at the bottom the atomic number. In the right hand side is the notation for the periodic table. In the center the atomic symbol, on top the atomic number, and at the bottom the atomic mass. Now let's practice. For the next example, determine the number of protons, neutrons, and electrons. Stop the video right now, do your calculations, and when you're ready, play it back so you can compare your answers. Good luck! In the next problem, calculate the average atomic mass for carbon, where carbon-12 has an abundance of 98.9 and carbon-13 has 1.1. Back again, stop the video, and when you're ready, play back so you can compare your calculations and answer. Thank you for watching.